Suppose we want to test the claim that the proportion of COVID-19 patients recover using medicine A is higher than using medicine B. So with this, we are testing the difference between two population proportion. So we are using independent samples, and we have two-tailed test and one-tailed test. So the null hypothesis will be P1 equals to P2, meaning that proportion from population 1 is going to be equals to proportion from population 2. So H1 will be not equal sign, less than or greater than. So when we write P1 equals to P2 for H null, it can also be written as P1 minus P2 equals to 0. So you're bringing the right side to the left. When comparing proportion of two independent samples, we are using z-test. So here we are assuming that N1 and N2 are sufficiently large. So because of this, we are able to use normal distribution as a close approximation to binomial distribution. So the test statistic will be z test z stat, which is going to be equals to P1 hat minus P2 hat over all this. So if you look at the P hat here, what is P hat? So P hat is x1 plus x2 over n1 plus n2, or we are using this P hat, which is the pool estimate of the population proportion, n1 P1 hat plus n2 P2 hat over n1 plus n2. So in this example, the Canadian Parliament debated the reinstatement of the death penalty. One of the factors was the amount of public support for the death penalty. In 1989, sample 1,500 Canadians revealed that 1125 favored the death penalty, and in 1999, 873 in the sample of 1200 supported the death penalty. So you have two population and two sample from it. The first sample will be 1200 and the second sample will be 1500. So the proportion for the first population will be 873 over 1200 and 1125 over 1500. So this is how you get P1 hat and P2 hat, which is 0.7275 and 0.75. And the question is, do these data provide sufficient evidence at the 1% significant levels to indicate that the proportion of public support for death penalty was lower in 1999 as compared to 1989. So if you look at this sentence, it gives you an indication that it is a one-tailed test. P1 hat is using 1999 and P2 hat is using 1989. So since 1999 is lower than 1989, so meaning we are claiming that P1 is going to be less than P2. So stating the null hypothesis, H null P1 equals to P2 and H1 P1 less than P2. So this is using population parameter. And alpha is 0.01. So since it's a one-tailed test, we do not have to divide this with 2. And we need to find the P hat. So P hat is the pool estimate of the population proportion. So meaning that you need to multiply P1 hat times N1, P2 hat times N2 over N2 plus N1. And you get here 0.74. And then you need to calculate the test statistic. So for the test statistic, we need to use the formula. So this is going to be P1 hat minus P2 hat over the square root of P hat. So P hat is what we did before here, which is 0.74 times 1 minus P hat. So 1 minus 0.74 is 0.26 multiplied with 1 over and 1 plus 1 over and 2. And we get here minus 1.324. So critical value, since we are using the left tail, P1 less than P2, so we are looking at the left side. So once we find the critical value for Z 0.01, which is 2.3263, we need to put the negative sign here because we are referring to the left side. And comparing the test statistic with the critical value, we found out that the test statistic minus 1.324 is larger than minus 2.3263. So it does not fall in the rejection region. So therefore, we fail to reject or do not reject H null. So the conclusion is that there is not enough evidence to indicate that the proportion of public support for the death penalty was lower in 1999 as compared to 1989.